Hi there! You're about to listen to a vintage episode of the Under the Microscope podcast. While the content is still as relevant and as interesting as when it was recorded, our webpage has changed. You can now find us at thesciencetalk.com/real-scientist-nano. Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. Hi everyone, today we have with us Marjorie Ladd Parada, who is a researcher at Stockholm University in Sweden. Hi Marjorie, how are you?
Hi, I'm very well, thank you.
Super. Let's start talking science. So please explain your research to us in super simple words, please.
So the most simple thing I can say is that I work on water at very low temperatures, below that at which it freezes. Okay. So I studied by using very strong X-rays and also by firing lasers at it. And this helps us see its structure and how it changes with temperature.
So how it changes with temperature when you go down or when you go up, like when it starts melting from freezing? Or do you do both ways?
Yes, we can do it both ways, although I have been focusing particularly on coming from the low temperature. But I don't usually go all the way to melting temperatures. I just stay in this very cold world because very interesting things happen here. And actually, we've just seen that water does not exist as only one liquid, but two liquids. So this is the kind of very quirky behavior that we are observing by using these techniques.
I am going to definitely ask you about the two liquids thing in the long podcast, but for now, is there an application in the real world for this research?
Okay, so actually, the reason why we're interested in water under these conditions is because, in fact, water is a very weird liquid. It's the most common liquid in our planet, and we're very used to it, but it's not normal. For example, when you make ice, it flows in water. Right. And this is very weird, actually, because a normal liquid, when it freezes, the molecules all pack together, and therefore the density increases and it would sink. So this is only one of water anomalous behaviors. And actually studying them, they observed that maybe all of these weird behaviors are stemming from a point at very low temperatures. And one of the hypotheses that had been proposed before only by theoretical and molecular computational studies was that actually there was a liquid-liquid transition at very low temperatures, so below 0 degrees,
right.
And all leading to another critical point, basically, where you have very strong fluctuations between these two liquids. The problem was that we could not study them before.
Okay.
Because the thing is that water tends to crystallize really, really fast, so become ice very fast at these temperatures. So we couldn't really see what was happening before this crystallization happened. However, thanks to these massive facilities called X-ray free electron lasers that measure at super speeds, we were able to see what happens before crystallization happens, and now we have seen experimental evidence. So if we have an understanding on how water is structured at these temperatures and what causes these anomalies, eventually maybe we can harness its properties for things like desalination of water or understanding how ice is behaving, in the poles.
Okay. Wow, that sounds cool. So there's quite a lot of interesting science that is happening. It's so fascinating. So I'm sure you have a lot of plans to talk about all different kinds of things. So What can the followers expect in the week that you will take over the Real Scientist Nano Twitter account?
Well, I of course think that one of the easiest things to think about is scientists are interested in water in general, of course,
Yes.
like water, and that are curious about ice because ice, there are so many types of ice, so they might be wondering what is going on. But besides the people that are interested in ice and water and maybe the X-rays applications, um, then I would also expect people that are not working in academia, but are interested in understanding what kind of research do we actually do, that might have never heard about these facilities, and once they learn, oh my God, there are these humongous facilities, kilometers in diameter, that people use to fire X-rays. Like, what are they for, right? What are these applications? So I expect people that are curious about science are understanding a little bit more about water.
Mm-hmm.
And yes, scientists that might have come in the interface of this research but don't really know much about it.
Okay, all right, that sounds cool. Oh, cool, huh?
I know that with this research, you can't stop making bad puns. It's like,
Yeah,
it's pretty cool.
it's super cool. Yeah, uh-huh. But it really sounds interesting and super, super, duper cool. And I'm personally looking forward to reading all about what you're going to talk about with the cold research and the water research. And this sounds definitely amazing. So thank you very much, Marjorie, for speaking with us, and looking forward to having you on Real Scientist Nano.
Thank you very much for the invitation.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.